Hello and welcome. In this video, we'll discuss some exam questions from the topic called forces and deformation. All questions discussed in this video can be accessed from the link given in the description. Let us consider the first question. In this question, we've been given three diagrams, and the question involves an experiment with spring. So it says figure 14 shows a spring standing on a table, and we've been given rulers. So before I carry on reading with the question, I would like to quickly assess this setup. The moment I see this ruler, I can see it goes up in very big increments. So I can say increments are too big, number one. Number two, I can also see, because I'll have to read the scale, and this scale is very far from the spring, so this distance is large. These are the two improvements that we can do to our system at this given stage. It says weights are added to the spring as shown in figure 14b and 14c. So they've added weight. Here is 1, here you have 2. It says estimate the original length of the spring as shown in figure 14a. So they are basically asking us to use this 14a figure to work out the length. So the good practice will be, I'll use my ruler. If you read the scale here, you will notice it is about 50, because it says estimate, so any value close to that value should be okay. So we can say it is 50 mm. The next part says describe how the reduction in the length of the spring when weights are added can be determined. If you have gone through the last video on this topic, you would have noticed that I gave you an equation to work out the extension. Now the same concept will apply here, but we are not going to measure extension. We will have to measure compression. So I'll say you'll measure length in figure 14a. This will be your L naught, meaning this is without masses. And I'll say measure length in the presence of mass. This will be our L. And then if I do to work out compression, I'll do L naught minus L, and this will give me the value of compression in millimeter. We can add a bit of more information here. This is without load. So just remember the concept. You have to measure two lengths to work out the extension or compression. Next part says state two ways that the experimental procedure could be improved. I already gave you the answer to this question at the start, because I annotated while I was reading the question. We can say use ruler with smaller increments. Number two, I can say move ruler closer. Can say move ruler closer to spring. I can do something more than this. How many times are they doing this experiment? Only 3 times. So we can say repeat experiment and calculate average. This question is a 2 marker, so you'll need at least 2 statements to gain those 2 marks. Next part says give one reason why the reduction in length eventually reaches a limit as more weights are added. So if you look at the diagram, if I keep on adding the masses on top of it, what will happen? The spring will eventually get fully compressed. Once it is fully compressed, it cannot be compressed any further. So we can say spring gets fully compressed. On this question, they have merged 2 topics together. So they've merged electromagnets with forces and deformation. So you can see here, you've been given a solenoid. So I can say solenoid means this is my electromagnet. So when the current goes in, then it will become a magnet. And if it becomes magnet, now I have magnetic material. What will happen in this case, induction will take place. And as a result of magnetic induction, attraction will exist between them two, and therefore the spring will move down. So we can get original value, which is the value in the absence of current here, and we can get another value from here in the presence of current when it moves down. So let's read the question and see what the question says. The question says a student sets up the apparatus shown in figure 9. When the current in the solenoid is switched on, the solenoid attracts the iron nail. And this is what I've just explained to you, that this will become electromagnet, induction will take place here. As a result of this, the nail will be pulled down. Describe how the student could use this apparatus to investigate how the size of current in the solenoid affects the force of attraction between the solenoid and the iron nail force. If we recall from our understanding, we know if the current increases in solenoid, then it will become more stronger magnet, meaning the magnetic field will become stronger. If magnetic field becomes stronger, it will apply bigger force on magnetic material. And this is what we are trying to investigate here. So we will have to change the value of current, and we'll have to work out the value of force. Now from this setup, we can see there is no way that we can work out the value of force straight away. Yes, current is straightforward. I can say use power supply to supply current. I can say record it using ammeter. So this is straightforward. Now we will need to work out the value of F, and this F can be worked out using equation F equals K times E, where E is the extension. So to work out extension, same concept will apply as we did on the previous question. So I'll say number 2, I can say record value on ruler at start. This means when there is no current. Number 2, I'll then say record, that's number 3, sorry, record value on ruler again once current is switched on. And then I can say number 4, my extension will be equal to reading 3 take away reading 2. Once I know my extension, number 5, I can then say to work out the force, I'll use equation K times E. Number 6, I can then say you'll have to repeat using different currents. One of the good questions, okay, where they have merged the two topics together to test your understanding in terms of can you relate concept from one topic to another topic. Next question is just a calculation question, so may involve unit conversion. It says here the spring constant of different springs is 24 Newton per meter. This is my value of K. So it tells me you will need 24 newtons of force to cause an extension of 1 meter. It says the spring is extended from its unstretched length by 12 centimeters. So this is the extension, because it says by 12 centimeter means is the value of E, but I can't use this as E. I'll have to change it to meters, and for that I'll have to do 12 divided by 100, which gives me answer as 0.12 meters. Then it says calculate the energy transferred. Calculate the energy transferred means we do not know the value of energy transferred to the spring. It says use the equation from the list of equations. The equation is half times K times E squared. You've got to be extra careful with this squared. This is the most common mistake that students make when they are doing their exam. They don't put this 2 on top and they lose a mark. So I can then say half times K has a value of 24 times by 0.12 squared. If you put it in your calculator, it will give you the answer in joules. The next question is about an object under water. So if it is about underwater, then this means this is about pressure under liquid. Here it says figure 17 shows a crane lifting a concrete block from the bottom of a deep pool of water. The top of the surface is at a distance h below the surface of the water. The force on the top of the block due to the water above it is 4100 Newton. So they are telling me that on this section the force here is 4100 Newton. So 1000 Newton is the value of F. It then says the pressure due to the water on the top surface of the block is 66,000 PA pascals. That's the value of P. So I know now, I do know the value of force and I also know the value of pressure. It says calculate the area of the top of the surface. I can write down the equation, which is standard equation, pressure equals force over area. So the value of force is 41,000, but before that I can replace P with 66,000. Value of F is 41,000 divided by A. You can put 1 in the denominator here, you cross multiply and solve, and this will give you the value of A in meter squared. It will turn out to be 0.62. Now the next part, it says the density of water is 1000 kilograms per meter cube. This is the value of density. Calculate the distance h between the top of the block and the surface of the water. So this means we do not know the value of height. They've given us the value of g as 10 newtons per kilogram. It says use an equation selected from the list of equations at the end of paper. Now before I carry on with this question, you will notice these two values were given at the start and then these subparts started. So this means these two values will be valid for the entire question. So in this question, we do know the value of pressure as well. And if you recall, when we talk about pressure underwater, we've got to use two equations. Pressure equals force over area, and the other one is pressure equals density times gravity times height. This time we will make use of this equation. We do know the pressure at this height. This is 66,000, so I can replace that with 66,000. Density is given to me as 1,000. Gravity is given to me as 10, and I don't know the value of h. If you solve this, you will end up with a value of h as 6.6 meters. Now it says explain why there is an upthrust produced by the water on the block. Again, if you go back to the last video on this topic, you will see I have described this situation. So we said you have an object which is underwater. It will have pressure at the top surface. It will have pressure at the bottom surface. P at top is less than P at bottom. To work out the value of force, what will I do? Force will be given by pressure times area. Area is fixed in this case. This is fixed. It can't be changed. Top and the bottom has the same area. So if the smaller pressure means smaller force. So I can say, because pressure at the top is smaller, so the force at the top will be smaller. While the pressure at the bottom is bigger, so the force at the bottom will be bigger. If I take the difference of these two, that will be my upthrust. Now this question is a 6 marker. It says the crane raises the block until it is high enough out of the water to be loaded onto a trolley. The block moves upward at constant speed. The moment I see this constant speed, this means F downward is equal to F upward. In other words, I can say the resultant force has a 0 value. So I can say acceleration will be 0. Says even though the lifting force in the cable changes. So they're telling us that the lifting force in the cable will change over time. Figure 18 shows the graph of how the lifting force changes while the block is being raised. So this is the graph that tells us how the lifting force is changing with time. It says explain why the lifting force changes. We have to explain this, why the lifting force changes as shown on the graph in figure 18. Include calculations in your answer. So two aspects. One is we have to explain why the lifting force changes, and the second one is we have to include calculations in our answer. So if I go back to this graph, I can say I can divide this graph into three sections. I'm going to say this is section 1, starting from 0 up until 120. From 120 up until 140, this is my section 2, and from 140 onwards, this is my section 3. We've been given one information that it moves at constant speed. This means the downward force will be equal to the upward force. We know that the block is underwater. So when something is underwater, there will be some forces acting on it. So what are those forces involved? In this case, up thrust plus the lifting force. They will be equal to the weight force, because weight is going to be acting downward while the other two forces will be acting upward. So for this situation, I can say my weight will always remain constant. For upthrust, as long as the object is underwater, the upthrust will be constant. Once it starts coming out of the water, then the upthrust will change and the lifting force will also change. Once it is completely out of the water, upthrust will achieve a value of 0, and now the lifting force will equal weight. Let's first talk about section 1. For section 1, I'm going to say upthrust is equal to constant, and I'm going to say lifting force is also constant as well. Now, to support this, I have to say, because upthrust plus lifting force will be equal to the weight, and therefore there is no change in value of force. Once I've done this, I can clearly see here that these two together are equal to the weight force. I can then say that weight is greater than lifting force in section number 1. I do have to tell them I'm saying upthrust is constant. Why? Because it is fully submerged. Now for section 2, I can say at t equals 120 seconds, the block starts coming out of water. I can say upthrust decreases and lifting force increases. Now, why is this happening? In this case, because less volume is being displaced. Then for section 3, I can say now it is fully out of water. So I can say at t equals 140 seconds, the block is fully out of water. When this happens, then I can say upthrust is now equal to 0 and lifting force will be equal to weight. So I've discussed the first section of the question where it says explain why lifting force changes. Now we have to include some calculations to gain more marks in this question. So if I go back to this graph here, I can see here, this is when it is completely out of water. So I can say this is my weight force. In section 1, I can say lifting plus upthrust is equal to weight force. So from here, I can work out the value of weight force. And if you look at it, the value of weight force will turn out to be 17.0 kN. The lifting force has a value of 10.2 here. It is. So I can then plug these values in. Lifting force has a value of 10.2. Upthrust is not known. I can call it X. Weight is 17. If you do 10.2 take away on this side and on this side is gone, you will be left with a value of 17 take away 10.2, which gives you 6.8 kN, and this is your upthrust. Now in this case, the upthrust, and this is my max, and then it starts decreasing, and at this location the upthrust is 0, which we have already mentioned in our answer over here. We can carry out more calculations on this data considering the data that has been given to us in question before. For example, let's say we worked out the height, which is 6.6 meters, and this is the height that we have. Now it took 120 seconds because the lift force never changed here, so the object remains fully submerged until time is equal to 120. So if you divide 6.6 over 120 seconds, that will give you the speed at which the block moved within the liquid. Once we know that speed, we know it then carries on traveling for 20 seconds while it is coming out of water. So we can also work out the height of the block. Those are the two other calculations which can be performed, but what you see on the screen is enough to gain 6 marks on a question like this. Next question says figure 8 shows some water in a tank. More water is added to the tank. So when you add more water, there will be two effects of this. Number one, this means more mass, and number two will be greater height from the base. Next says explain how the pressure on the bottom of the tank changes when more water is added to the tank. So we can answer it in two ways. We can use equation P equals force over area. We can say more mass of water, therefore force will increase, hence pressure will increase. We can also use equation pressure equals density times gravity times height to answer this question. We can say more mass means greater height from the base, therefore we can say P will increase. Next part says figure 9 shows an object on the bottom of the tank of water. Draw an arrow on figure 9 to show the direction of force exerted by the water. Force exerted by the water on the surface of the object at point X. We did discuss it in our last video as well. The force is always at 90 degrees to the surface. So the force will be at this location and the angle will be 90 degrees. Next question says another spring is extended. The work done to extend the spring is 0.14 joules. So this is my E, because work done is energy transferred. The spring constant of the spring is 175 Newton meter. This is the value of K. It says calculate the extension. We do not know the value of extension. I'm just going to write down the equation as E equals half times K times X squared. All I have to do is replace it with the values. There is no unit conversion in this case, so it will be 0.14 equals half times the value of K is 175 times X squared for extension. Now I can put this in my calculator. It'll change to 0.14 equals 87.5 X squared. We divide both sides by 87.5. 87.5. This is gone. You're left with X being equal to 1/625. I'll need to take square root of this, and your answer will be 0.04. The question says a student carries out an investigation to show how pressure varies with depth in water. A pressure sensor is attached to a ruler. The ruler and pressure sensor are lowered into the water in a tank as shown in figure 8. They've shown us that the ruler and the sensor is lowered into the water. The depth of the pressure sensor below the surface of the water is read from the scale on the ruler. The pressure is displayed on the student's mobile phone, which receives a signal from the pressure sensor. Figure 10 shows a graph with the results plotted. So here are the results. In this case, the depth is 0 here. So this means this is the pressure on the surface of water, which is basically P atmosphere and will never change. Now it says the student repeats the investigation using seawater and draws a graph for the results. So now they are using seawater, so density will be different. Say the seawater is more dense than the water used previously. Compare the graph of seawater with the graph in figure 10. So if I recall my equation is P equals density times gravity times height. So in this case, these two are same, but this is now more than the previous case. So if the density increases, the pressure will increase. So I can say number 1, pressure will increase. Because it's 2 marker. If you read, it says compare the graph. So if you were to plot the graph of seawater, then how will it look similar and how will it look different? So we've already said that the pressure will increase. The pressure values will be higher. However, the starting pressure will be same. If I'm to sketch this graph on this for the seawater will look like this. So the starting value will be same, but for the same depth, it will have a higher value of pressure. Next question says the student investigates the stretching of a long piece of rubber. Figure 15 shows the apparatus to be used. The student, so they've got a bench, and on this bench you have tied the rubber here, you've got the hanging mass here, and you've got a pulley. So when you put loads on this end, the rubber will extend. The student puts just enough weight on the weight hanger to make the piece of rubber just tight. The student wants to plot a graph to show how the extension of the piece of rubber varies with the force used to stretch it. So in this case, measurement of force is very easy. All they have to do is they can work out the mass here and they can work out W equals mg, and that will give them the value of weight. However, extension is a problem in this case. So how are they going to work out the extension? Say the student adds a known weight to the weight hanger. Describe how the student could measure the extension. How could they measure the extension of the rubber when he adds another weight to the weight hanger? So we can say in this case, they can mark 2 locations, A and B. So you mark 2 points on the rubber, and then you will measure the length before putting the weight, and then you will measure the length again once you have placed more weight here, and then you will work out the difference. So I can say here, mark 2 points A and B as shown above, and record distance between them. Number 2, I can say, then add weight and record new distance between A and B. So extension will then be given by value 2 take away value 1. That will be my answer. Next part says the student obtains a series of values of force and extension while loading the piece of rubber and then unloading it. So while you're loading, this is the graph. So this means all area under this graph is my work done, or I can say energy stored in the rubber while it was being loaded. When you started unloading, it gives out only this much energy. So I can say this shaded area is energy lost. It says explain how the shape of this graph shows that the distortion of the piece of rubber being stretched is different from the distortion of a spring being stretched. The two components in this case are rubber and spring. For rubber, the graph has already been given. For the spring, you have to recall. For a spring, it's a straight line for force extension passing through the origin. I can say for spring, the graph will be a straight line passing through origin. Last question on this sheet. It says figure 13 shows a diagram of a device for lifting heavy loads. So we've been given a piston here and we've been given a piston here. It says the metal tube is filled with oil. The piston Y is pushed down with a force K. This produces a force L on piston Z. So when you press it from the right side, you'll make this piston go up. The pressure exerted on the oil by piston Y is same as the pressure exerted by the oil on piston Z. So this is something that is important for us to remember. So in this case, my pressure is equal to constant. We know the equation for pressure is force divided by area. So if I keep the left side constant, if my force increases, my area will have to increase. If my force decreases, my area should decrease. Now it says explain the difference between the size of force K and the size of force L. So we can make two sections, K and L. Let's have a look at area and area. So when it comes to the area of K, it is small. Here the area is large. So if I look at this equation, larger area means bigger force. So I can say force on L will be large, but the force on the K will be small. With this question, we'll conclude our video. I hope you have found this video useful. Please give it a like, share it with your friends, and to stay up to date with the content being published on my channel, kindly press the subscribe button. I wish you all very good luck with your exam preparation. Thank you.